Hello. This video is about some of the applications of the zero values of the polynomials. So, first of all, uh, this is its application, that how to check whether any zero value is how any number is zero value of the polynomial or not. Suppose this is a polynomial p of x is equal to x cubed minus 2x squared minus x plus 2. And we have to check whether this x is equal to minus 1 is the zero value of this polynomial or not. So how can we check this one? So what we have to do, we have to substitute this x is equal to negative 1 in this polynomial p of x on both sides in place of x. So negative 1 cube, negative 2, negative 1 square, negative 1 plus 2. This is 3. So negative 1 raised to power 3, this is negative 1, and this is negative 2, this is plus 1, this is plus 2, this is equal to 0. Since we have set this x is equal to negative 1 in this polynomial, it gives us 0. So what does it mean? It means that x is equal to negative 1 is 0 of polynomial p of x. So if this is not equal to 0, this answer, if this is not equal to 0, then we will say that this number is not 0 of the polynomial. So for the number to be 0 of the polynomial, this should return 0. So next is types of zero polynomial, types of zero values. Suppose we are given this function and polynomial function, and this is the factorization of this polynomial function. These are the factors of the polynomial functions. So if you want to find the zero values from this factorization, you have to use the zero product property, which we have studied to earlier. So how can we find this? This we have to set this f of x is equal to 0. So this will give x plus 1 whole cube x times x minus 2 whole square. This should be equal to 0. So we have to set this x plus 1 cube is equal to 0, x is equal to 0, and x minus 2 whole square is equal to 0. So we can get from here x plus 1 equals 0, x plus 1 equals 0, and x plus 1 equals 0. We have to write this x plus 1 3 times. So this is x is equal to negative 1, x is equal to negative 1, and x is equal to negative 1. So why we have set this x plus 1 3 times equal to 0? Due to this exponent. Okay. So next, what we can do, so this negative 1 is said to be, this is called triple value. This is triple value of the function. Negative 1 is called triple value of polynomial f of x. So what next we can do? Now next, this is x is equal to 0. So x is equal to 0 is single zero value of polynomial f of x. So what next? Next, this is x minus 2 square is equal to 0. So from here, we can set it twice equal to 0. X minus 2 is equal to 0. X minus 2 is equal to 0. Why we have set this x minus 2 twice equal to 0? Because it is giving us x is equal to 2 and x is equal to 2. So this x is equal to 2 is double 0 value of this polynomial f of x. So these are the types of the zeros. It depends upon the number of times the root is being repeated. So if someone asks you to find the distinct values, so distinct values are -1, 0, and 2. But we know that this -1 is being repeated 3 times, so it is called triple value of polynomial f of x. This 0 is being repeated once, so this is single 0 value of the polynomial f of x. This 2 is repeated twice, so 2 is called double 0 value of the polynomial f of x. So in factorization, like that in this case, which example we are recently discussing, uh, if anything is being repeated more than once, like this is x plus 1 cube, x minus 2 is equal to 0. So since this x plus 1 is repeated 3 times, so we say that this is threefold value. And if anything is repeated twice, like this x minus 2, this is called twofold value. Anything which is repeated once, this is one-fold value, like that. Hopefully you have understand these things. Next, there is an application of the zero values. So suppose we are asked to find the polynomial rule. So I have, by using the zero values, we have to use zero values here to find or formulate the rule of the function of polynomial function. So I have this example, a cubic function. Cubic function means a function whose degree is 3. Degree means highest exponent of x involved in any polynomial. So we have a cubic function. So any degree of the polynomial function or degree of the polynomial represents the number of roots or number of solutions of the polynomial. A cubic function has a single zero value, which is -2, and a double zero value, which is 0. It means that this function has -2 root, which is uh, appearing only once, and 0 as other root, which is being repeated twice. So how can we make the function from this? Also, this point 3, -3, 8 is given, which is lying on the graph of this function, which is under our discussion, which we have to find. So we have to find the rule of this function. So our values are, single value is -2, so we will write this x is equal to -2, and other value is 0, and 0 is double value, so we will set x square is equal to 0. So now we let that f of x is the required polynomial. You can name it anything, p of x or g of x or h of x, anything. So we have to write here a, which is unknown. We don't know about this. We have to take -2 on this side. So this will become x plus 2. So also we will write here x square. This polynomial has degree 3. It is clearly visible that if we multiply x square inside, then uh, this will become x cube plus 2x square. So this polynomial f of x has degree 3. So that's why this is called the cubic function. Now we have to use this point here, negative 3, 8, because this a is still unknown. So how can we use this negative 3, 8? On the graph, first coordinate actually represents the x value, and second point actually represents a value of function which is f of x. So this f of x is equal to 8. This f of x is equal to 8. We will write here 8 a times uh, this point is 3, not negative 3. This is plus 3. So plus 3. We will write f of x is equal to 3, while f of x is equal to 8. So 8 is equal to a times 3 plus 2 times square of 3. So this 8 is equal to a times 5 times 9. So this 8 is equal to 9 a times, this is a. This is a times 45. So what is the value of a? Value of a is 8 divided by 45. So in the above function here, we have to substitute this value of a. So this f of x is actually equal to 8 divided by 45, and this is x plus 2 times square of x. So this is the required polynomial which we have to find. Hopefully you have understand this. So this zero values are helpful to find the function also. So like in this example, negative 2 was the single zero and 0 was the double zero. It means that uh, negative 2 was appearing only once uh, in this function, and 0 was repeating twice. So it means that x square is equal to 0 and x is equal to negative 2. So we have taken this function f of x, and we can write this a times a is any unknown constant, because we don't know what is the coefficient of in this function here. So we have to substitute here a. So x plus 2 and x square. So this a was unknown to us. So we calculated its value by using this point 3, 8. So its value came out to be 8 over 45, and we substituted back value of this a in this function here. So this is our function. So next is another very quick way how to uh, factorize a polynomial from zeros which are given. Suppose uh, we are given these zeros, x is equal to 2 by square root of 3, x is equal to negative 5, x is equal to 1, and x is equal to 2. So how can we find the polynomial f of x? Suppose these are the zeros zeros of some polynomial p of x. Then write or find factored form factored form of p of x. We have to write the factored form of this polynomial. So we have to find the factored form of polynomial p of x, or we have to find just polynomial p of x. This can also be written like that. So how can we write? We will write here this p of x. So this is equal to x minus 2 over square root of 3. We have to take this on this side, and similarly we have to take this negative 5 on this side, x plus 5, and next we have to take this 1 on the other side, x minus 1, similarly this x minus 2. So this is the factored form of the polynomial p of x. So the number of zeros of any polynomial actually gives us the polynomial function. So these are the if these are four different zeros, then we should have a polynomial of degree 4. So any polynomial of degree some n degree, this will have maximum of n factors, because any polynomial can also be of this form, like that this p of x is equal to x minus 1 cube and times x plus 2. So what is the degree of this polynomial? Degree of this polynomial is 4, but its different roots are different zeros are x is equal to 1 and x is equal to negative 2. So number of zeros of any polynomial are less or equal to the degree of the polynomial. Like you can see that in this example, the degree of polynomial p of x is 4, but its zeros are 2. It has two zeros, two different zeros. So number of zeros are actually less than or equal to the degree of the polynomial. Thank you.